Hello everyone. So today is gonna be our day 28 of the DSA challenge, and the question that we're gonna solve today is remove nth node from back of the linked list. This is the question, right? This is a medium type question and has been asked in Facebook 23 times, Amazon 10 times, Microsoft, Google, and all these. Basically, all the fan companies have asked this question, right? The question is fairly simple. Given the head of a linked list, remove the nth node from the end of the list, right? So, if this is the linked list given to you, right? This is pointing to null, and n is probably given to you, let's just say 2, right? So, what is the second from the last? So, this is 1, this is 2. You have to remove this element so that your resulting should look like simply this. Do you see that 4 is not here, right? So how will you do this question? Had it been given that you have to remove it from the starting, you could have done it easily, right? You could have said like probably n is equals to 2 from the start. You would say that hey, temp is here. Then if basically you have to remove your temp using, if this is the 2 thing and this is, let's just say you are at 1, what you can do is if temp basically if your temp is at n minus 1, then hey, this dot next is equals to this dot next, this can point to this, and simply 1 3 4 5 would have been your answer. But now what can we do? Okay, let's just draw it again. Let's just draw the list again. So this is 4 and this is 5, and n is given as 2. Great. uh, how can I reach this point, right? How can I reach this point? This is important. Okay, first of all, I need to know the length of it. So we are discussing the naive solution. Naive solution. Okay. I need to reach some at this point, right? How would I know that, hey, this is the n by this is the n is equal. This is the nth position that I need, and this is that n minus one position, right? Which I need to say that, hey, your next should be your next. That is this point. Okay. Let's try to have a count variable, which will initialize from 1. Head is given, I will initialize a temp again, right? Like I usually do. So temp goes here, count becomes 2. Goes here, becomes 3. Goes here, becomes 4. And this goes here, this becomes 5, right? And this dot next is if it's null, then you can return. Or you can initialize it with 0. And every time you move, as soon as you reach null, you can then, whatever you want to do. This is my personal thing, so I can do that. So now I know that, hey, length is nothing but 5, right? 5. I will again bring my temporary back to my head. So this is given. And this time I know that, hey, my result will be what? I need to reach this point. And what will this point be? Length minus n. Am I right? Because if a length is 5 and n is 2, then I'm reaching this point if this becomes 3, right? Okay. So head is given here, temp again comes here, right? I can change the color so that it does not, overlap and make it look uglier. So okay. So maybe I can say that, hey, um I will say that, hey, len minus n minus minus, right? As it turns here, temp as it turns here, it should be equal to 0, question mark, right? Basically, I'm asking that, hey, is it 0? Is it 0? Okay. If it is 0, then hey, I know that again, you already know like this dot next, right? This dot next should be this dot next, correct? So then I can obviously do that. That is fine. But what is the time complexity? That is something we need to discuss. O of length for sure, for finding the length of it. Okay. And simply O of length minus n for traversing till here when we'll assign it to the next dot next, correct? This is this. And space complexity, obviously we are not using any extra space, but yeah, so this is going to be O of n. What is this worst case? This worst case will be O of length only. What if n is given is equals to your length? That means you have to remove your head. That is an edge case. That is an edge case as well. So in that case, what you will return head dot next. That is this one. That is this one. So in the worst case, this is equal to O of 2 into length, and this is not required because it is traversing two times, right? We don't need it. We don't need it, right? Okay. Can we optimize it? Optimize this approach only? Can we do that? I think we can. I think we can. Okay. Let me draw it first, right? Okay. Cool. Hmm. Now tell me one thing. Tell me one thing. What if, what I, if I have to reach this point, how many points did I need to move? I needed to move three steps, right? Because that was length minus n, right? Length minus n. Okay. That means two steps are left from behind from the last of the linked list. Just remember this thing. N points from the last will be equal to the rest. N points from the last, from the length of it basically, is equal to the rest. Fine. Let's use that. Let's use that. But you will say, Rohan, I don't know the length, right? If I have not traversed it, I know that, hey, 5 minus 3 will be equal to 2. If I need to find this, I need to know this, right? Then only I'll be able to calculate this. Yes. But I don't know this. I don't know this. But what if I tell you that, hey, you can know this also in this single pass? Okay. Okay. Let's put a slow pointer here. Sorry, and a fast pointer here. Here, like traditional slow and fast pointer, this will not move slow as one pointer and fast as two pointers. This will not move in that way. But why did we need to name it as slow and fast? Then we could have named it anything else, temp 1, temp 2, temp 3, temp 4, whatever you wanted to do. But why slow and fast? Because see, I'll tell you something. Okay. Let's do one thing. Let's move fast to 1, 2, 3. Basically, I need to move it 2 points. I need to move it two times basically, right? This is one traversal, fast comes here, and this is two traversal, fast comes here. Okay, fast comes here. Just hear me out, okay? This is moving two times, fast comes here. Now this has moved 0, 1. Basically, you can say that hey, this has moved two times. Okay. Now move your slow pointer and fast pointer by one times again. Slow, fast, slow, fast. Till what position do you need it? Till what position do you need to move it? Let's think. Here I know that hey, my slow pointer is the one that I need, right? This because this slow dot next will be my pointer which I need to delete, will be my node which I need to delete. And where is my fast? Its next is equals to null. Its next is equal to null, right? So basically, while fast dot next is not equal to null, I need to use slow is equals to slow dot next, and fast is equals to fast dot next. And when this has done, I'll say that hey, slow dot next, you become equal to slow dot next dot next. Basically, this dot next, this point, and this has now been deleted from the list. This will be removed, and this will now use look like a normal thing, right? This will now, and you can now return head. Okay. What if, what if your slow pointer is your basically your fast pointer becomes null? What if your fast pointer becomes null when you are moving it? When you are moving it. So, um, in the first, when you will say that, hey, let me remove this. I will say that, hey, for I equal to 0 goes till n minus 1, fast is equal to fast dot next. Okay. If I am moving it n times, basically n minus 1 times or n times, whatever you can say, right? If my fast is equal to null, if your fast is becoming null, let's see how you can do that. Okay. So if my fast was here, okay, and let me do one thing. Let me change the color, right? Blue, maybe. Fast is here, then here, 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 and here, and here, right? What is the particular thing that will be given to me? What will be the particular thing that will be given to me? Basically, n is given to you as maybe, uh, the complete length. The complete length, that means you need to remove this. You need to remove this, right? You need to remove the head of it. You will say that, hey, return head dot next, return head dot next, correct? And so this has been done, right? This loops run for O of n. This loops run for O of almost of length, because some will be left from behind and some will be traversed again. So O of length, and you are returning it. So time complexity becomes O of length plus O of n. Space complexity becomes O of 1. This is your optimal time complexity. Do you remember that it was initially running for 2 into length? Although, see, obviously, this also, n can also be equal to length. It can also be equal to length in the worst case. But we are tackling it here only. Where is it? This if condition. Then also it will go till O of length only, right? We are not coming till to this point. We are not coming to this point. Great. Let's try to code it up. So let slow is equals to head, fast is equals to head, right? Move, move my fast pointer till 0, till n. I is equals, I is less than n, I plus plus, and fast, you become equal to fast dot next. Great. If fast is equal to null, then return head dot next. Else, else, while my fast dot next, you are equal, you are not equal to null, I will run a loop. So slow is equal to slow dot next. Fast is equal to fast dot next. Let's console out the slow and fast first, so that we can see that, hey, where is our slow and where is our fast. So slow is at 3. if you can see that first element is 3 and last pointer is at 5, right? For other cases, for case this, slow is at, where is it, output. Basically nothing is the output. That means you have to so this is this, that means you have to return that next position, which will be null, so that is why also it is coming, like this, because we have returned from here. And in this case where this is this, you know that hey, slow is at 1 and fast is at 2. This is what we required. We required n minus 1 position. That means my maybe let del node is equals to slow dot next, correct? This is the position that I need to delete. This is the node that I need to delete, slow dot next. Okay. So I will say that hey, slow dot next, you become equal to del node dot next, correct? That means 4's next will be 5. So 5 will become 3's next. 5 will become 3's next. And del node, your next should be equal to null. I don't want you. I don't want you. Right? And I can say that, hey, return maybe head, right? And let's try to run it now. Accepted. Let's try to submit it. And accepted, right? Accepted. We have discussed the time complexity. You can obviously use a delete function here that will delete it from the memory as well. I'm not sure if in JavaScript, basically, no, a garbage collector is there. Is there uh, is there an inbuilt garbage collector in JavaScript that is called a garbage? It monitors an object that becomes unreachable. So I think there is already one. So I don't think you need it. I don't think you need it. So okay, you can remove this, but in, I guess, in C++ you probably need, you say that hey, free, del node, because I don't think there is a you know an automatic garbage collector. So yeah, this is the time complexity, this is the space complexity. Why we use slow pointer and fast pointer? Because every since fast pointer will be always ahead of slow pointer. This is what the condition of slow and fast pointer was initially, if you remember, right? When we discussed the tortoise hare approach, basically. And here also it is doing the same. Slow and fast pointer does have a difference between them. And that difference is the main thing. That difference. So slow and fast, right? When fast reaches here, this is the point that I know that, hey, this will be the point where my slow will initially come, right? Initially come. Though obviously n could have been 3, n could have been 3 as well, and the length could have been anything. But as soon as slow pointer comes here and my fast dot next becomes equal to null, I know that you have to point to the next position. You are the n minus 1 position, right? Uh, let's use this. Use slow and fast pointer, but not traditional one. Move past n times, then bring your slow to a position where move now move slow and fast pointer one time, uh, single pointed till fast dot next becomes null. This, your slow will be at n minus 1 position now, and you can do the rest, right? Let's save this and mark this as done. add two numbers. This is the question that I will say that, hey, out of all these five questions or maybe linked list, this is very important and is probably, let's just see. So it is asked in Google, Bloomberg, Facebook. I'm not sure where is it has been asked or not, but it is real. It is one of the most important question, and you need to know few things for this thing, right? So yeah, we have done it, and I'll see you tomorrow with this video. Add two numbers as linked list. So thank you so much, guys. Bye bye.